Hello all, my name is Ashutosh Rastogi. I'm a teacher by profession. My mission is to impart quality education for all. For that purpose, I'm creating these videos. If you appreciate my work, then please do like my video and subscribe my channel so that I could get the motivation to prepare more videos. Anyways, today in this particular lecture, we are going to discuss about the introduction to your cellular concepts. So these are the outlines. We're going to start up with the introduction where we're going to describe whatever we have studied in our earlier lecture. Then we're going to discuss the basic concepts of your cellular system, which will be followed by the basic architecture of your cellular telephone system. Then we're going to discuss about your forward and reverse channel. These are basically your frequency bands over which your signal transmission will going to take place depending upon whether mobile station is transmitting to your base station or base station is transmitting to your mobile station. Then we're going to discuss the anatomy of a cellular call, that is how the call from a mobile station to mobile station will going to take place, or from your landline user to the mobile user will going to take place. And finally, we're going to discuss what is frequency usability and what is its need. So in our earlier lecture, we have discussed about the introduction to your wireless communication systems. We have also discussed various types of existing wireless communication systems such as your cellular network, satellite network, millimeter wave communication, LMDS, etc. So now we are going to discuss the basics of cellular concepts which are essential for cellular planning. So here idea is, if we have to plan a communication system into a specific region, then how frequency planning will going to take place, or what are the various important points that we need into the consideration. So now we're going to discuss the basic concepts of your cellular system. So high capacity is achieved by limiting the coverage of each base station to a smaller geographical location called cell. Here you all should keep in mind that we have to plan a cellular communication system and what are our needs and how we will going to fulfill them. So as of now, just consider that if we want to deploy a communication system, then we need that high capacity must have been achieved, and it would have been achieved by limiting the coverage region of a base station into the smaller location, and the coverage of that station would have been called as your cell. So then same frequencies, time slots, codes are reused by specially separated base stations. Just in order to avoid the interference, we can use same frequencies or the time slots or the various orthogonal codes in your geographically separated base stations. So obviously if we can transmit our signal into these signaling units, then we can avoid the interference. So a switching technique which is called handoff enables a call to proceed uninterrupted when one user moves from one cell to another. Since in your wireless communication, important point is we are providing mobility to the individual user, and in this particular scenario, if a particular user is moving from one cell site to another cell site, or the coverage of one cell to another cell, then we must have to employ certain technique so that its call will not going to drop, it will going to continue. So it basically resolves the problem of limited radio spectrum. If we will going to follow all these points that we have discussed above, it will basically going to resolve the limited radio spectrum. So what else we will going to do is, we will going to provide neighboring base stations are assigned different group of channels. Here by channels we mean that frequency bands. So we have to provide neighboring base stations different frequency bands just in order to minimize the interference. Just because if all the base stations will going to follow the same frequency bands for their signal transmission, then anyhow interference will going to take place. If we want to minimize it, then we have to give different frequency bands to the different base stations so that interference may be avoided. So by systematically spacing base stations, and the channel groups may be reused as many number of times as necessary. Since for the occurrence of interference, we must have to have two or more signal transmission over the same frequency band at the same time and at the same space. If we will going to space them apart so that no two same frequency component will going to overlap with each other, then that will going to serve the purpose. So as the demand increases, the number of base stations may be increased, thereby providing the additional capacity. So obviously if we need to support larger amount of capacity, then we have to further deploy more number of base stations. But here the key point is we have to reduce the cell size, and how we basically going to do it via limiting the power of the base station. So this particular figure is basically showing the basic architecture of our cellular telephone system. It is basically the composite structure where our cellular system and our traditional PSTN system are coexistent. So this particular figure is basically showing your cell, this hexagonal structure, As of now, just consider them. It is the coverage area of this particular base station. This is the coverage of this base station, and this is the coverage of this base station. All these base stations would have been connected with your MTSO, which is nothing but your mobile telecommunication switching office, which is acting as your intermediate node, which will going to support the call from this mobile subscriber to the PSTN network, and from PSTN network to this mobile user. So this is the basic architecture of your cellular telephone system. So now we're going to discuss different types of channels or frequency bands over which signal communication will going to take place. So here, depending upon at which particular point signal information would have been initiated and at what particular point it will going to get terminated, we have defined this particular terminology. So first one is your forward voice channel. So we just need to understand it explicitly, that what does actually mean forward voice channel. So voice channel means here in this particular frequency bands, we will going to transmit our voice traffic. And forward means if signal would have been transmitting from your base station to the mobile station, then we will going to call them as your forward. And if signal would have been transmitted from your mobile station to the base station, then it would have been called or termed as your reverse. So this is certain specification by which we will going to designate our channel. So we need two sorts of signaling. That is, number one is your traffic or voice signal that we really wanted to transfer from one point to another point, and second one is your control signaling, which will going to essential to make sure that our signal transmission will going to take place properly. So depending upon traffic, we will be having two types of traffic, that is your voice traffic or your signaling information. And depending upon the signal flow, signal would have been either transmitting from your mobile station to your base station in your reverse link, and if signal would have been transmitting from your base station to your mobile station, then it would have been considered as your forward link. So first one is your forward voice channel. The abbreviation we use for this particular thing is your FVC. So it is used for voice transmission from your base station to the mobile station. Second one is your reverse voice channel. Abbreviation is your RVC. So it would have been used for voice transmission from mobile station to the base station. Then another one is your forward control channel. Abbreviation is your FCC. So it is used for initiating a call from the base station to mobile station. So here we have used this particular term, initiating a call, although there has to be lots of control messaging or signaling exchange through this particular thing. But as of now, just consider that if a base station want to initiate a certain call, then it will going to use this forward control channel. Whereas in your reverse control channel, suppose if your mobile station want to initiate a particular call, then it will going to use this reverse control channel. So hopefully scenario would have been clear to you. So now we're going to discuss that how a call will going to take place. So a cell phone, when turned on, though yet not engaged in a call, scans the group of forward control channel to determine the one with the strongest signal. So here in this particular scenario, we are assuming that a person have just switched on its mobile phone. Obviously it is having the SIM card. So if in this particular case it will going to switch on its mobile phone, then what will going to happen first? First of all, it must have to register itself to the servicing base station. So how it will going to do it? It will going to first scan the groups in your forward control channel to determine which base station signals it is catching and which is the strongest one. So it monitors the channel until it drops below the usable threshold. It then scans for another channel which is the strongest. So suppose if you haven't initiated any call, but still you are in the contact with your base station, and as soon as you are finding that the signal from a particular base station is dropped down to below a particular threshold, then it must have to rescan and connect with the another serving base station. So control channels are defined and standardized over the entire area of service. Typically the control channels used up to 5% of the total number of channels. Since frequency bands are fixed over which we have to deploy or make our communication system, so we will be requiring frequency channels for two purposes, that is for traffic flow as well as your control signaling flow. So what we will going to do is we will going to use 5% of the available spectrum for the control channel. They are basically reserved, and for 95% of the frequency band or spectrum we will going to use for your voice traffic. How a call to a mobile user will going to take place? So the MSC dispatch a request to all the base stations. The mobile identification number is broadcast as a paging message over all FCC throughout the service area. So first point is, if you have initiated a particular call, then how we will going to detect a particular subscriber or user to which that particular call has been made. So here in this particular case, your MSC will going to dispatch a request to all its connected base station, the mobile identification number. Obviously, you may consider it as your mobile number, your cellular mobile 10-digit number. It would have been broadcasted as a paging message over all the FCC throughout the service area. So the called number or the number to which you have made a particular call, it would have been broadcasted to all the base stations connected with your MSC in your FCC or your forward control channel. So the mobile station receives the paging message from the base station it is monitoring. So obviously, if that call would have been generated for that mobile station only in that particular case, that mobile station will going to respond that request to your base station that look, this particular is call for me, and that particular signal flow would have been done over your RCC, that is your reverse control channel. Then the base station conveys the handshake to the mobile switching center. The MSC instructs the base station to move to an unused voice channel. So base station makes this bidirectional connectivity and it will going to give this information to the MSC. Look, this message is for a particular user which would have been connected with me or taking services from me. So now MSC will going to instruct to the base station to move to an unused voice channel or free frequency band. So the base station signals the mobile station to change over to free forward voice channel or reverse voice channel. So as the base station got the directions from the MSC, it will going to signal to your mobile station to change over to the free forward voice channel or reverse voice channel. Obviously, for transmitting as well as receiving its voice signal, they must have to get over a free voice channel and RVC. So since we are talking about your bidirectional connectivity, so we must have to have both this forward voice channel as well as your reverse voice channel. So now a data message which is called alert is transmitted over your forward voice channel to instruct the mobile station to ring. So as soon as all this process would have been accomplished, then a data message would have been transmitted to instruct the mobile station to ring. So all these sequences of events occur in just a few seconds and are not noticeable to the user. So while the call is in progress, the MSC adjusts the transmitted power in order to maintain the call quality. Obviously, if received call quality will get deteriorating due to the movement or any other thing, then MSC must have to adjust its signal power so that receiver will going to get optimum SNR and its call quality will not get suffered. So next is a call from a mobile user. So suppose a call would have been generated from a mobile user. Then a call initiation request is sent to the RCC. Since mobile user will going to generate a particular call, so it will going to transmit it information over your reverse control channel since it is requesting to your base station. So along with this, the mobile station transmits a mobile identification number, which is nothing but your 10-digit mobile number, and its electronic serial number just to authenticate itself. Nowadays, we will going to call them as your IMEI number, that is International Mobile Equipment Identity Number. It is the unique number and the phone number of the called party, that is to whom it has initiated the particular call. So the mobile station also transmits the station class mark, which basically indicates the maximum transmitted power level for a particular user. So it signifies itself that what will be the maximum allowable signal power. So all these information would have been sent by your mobile station. Then the base station forwards the data to the mobile switching center, which validates the data and makes connection to the called party through the PSTN. Since here a mobile user want to connect to a user of your landline, so it must have to connect its call through the PSTN, and MSC will going to take the responsibility of validating and all other things at the backend. On the other hand, if a particular mobile user have initiated a particular call to the mobile phone user only, then PSTN will not going to comes into picture. Your MSC or MTSO itself will going to take care of all those factors and call would have been connected. One important point I would like to share at this particular moment is, although nowadays One India plan is there and all calls would have been free, but several years back, if you have used your mobile systems, then in that particular scenario or situation, your mobile to mobile call is cheaper rather than your mobile to landline calls. The reason is clear that in your mobile to mobile communication, you don't have to access another infrastructure related to your PSTN or your gateway MSC. So that is why those calls are cheaper. And if you want to connect with your PSTN network, then you are basically using large number of network resources. So for that sake, your call will be expensive. So although nowadays this is not the case, all the things are free and there is no concept of roaming also. So subsequently, as we proceed this particular lectures, we will going to discuss what are they and what is their structure now. So now we're going to discuss a very important concept, that is your frequency reusability, the need. So just in order to understand this frequency reusability concept, let us understand a particular scenario. Suppose that fixed telephone networks runs wires to every household. So this is your wired infrastructure network, and suppose we have given every household or subscriber their own frequency spectrum for analog speech, which is containing of your 4 kilohertz band of bandwidth. So if for individual users we have allocated this 4 kilohertz frequency band for its voice communication, then what will be the bandwidth requirement for that? So let us consider the case of your Uttar Pradesh, where we are assuming that there are 12 million subscribers are there, and if each and individual subscriber is having this 4 kilohertz bandwidth, then the bandwidth requirement for this communication system will turns out to be your 48 gigahertz. So which is such an enormous bandwidth, and this much amount of radio spectrum is not available for our cellular communication system. Since it is not possible to have such a large spectrum, no other service is possible using the radio transmission. Suppose if we are going to make it true, then also while using this enormous frequency spectrum of 48 gigahertz, if we will going to occupy whole radio band, then we cannot have the possibility to use any other radio transmission rather than our cellular communication only. So most of the spectrum remains unused most of the time. So here this is the key point, which will basically going to gives us the idea that we may reuse the frequencies for our communication system, and it basically allows us to a basis to perform proper frequency planning, so that we are in a state to develop your cellular communication system where we are reusing our frequency bands, and via effective planning we are trying to suppress that interference effect or design an effective communication system. So this is the basis of your frequency reusability and its need. So cellular radio spectrum rely on intelligent allocation and reuse of channel throughout the geographical coverage. We will going to allocate intelligently frequency bands to the individual base stations or cells throughout the geographical area. Then each base station is allocated a group of radio channels to be used within the small coverage area of its cell. So here important point is individual base station is responsible or initiate as well as receive its call to its allocated bandwidth only or to its allocated spectrum only. Neighboring base stations are given different channel frequencies from others. This would have been done so that we could limit the interference. So by designing of antennas, the coverage area is limited within the cell, and the same group of frequencies is reused to cover another cell which is sufficiently distant apart. So here we are using this particular point distance, since it is the basic signal transmission phenomena that after certain distance signal strength will going to get deteriorated or reduced due to attenuation. So we are basically exploiting this particular thing, and we are reusing the same frequency bands after certain distances, so that the impact of co-channel interference will be limited, or we could avoid the interference effect. So the design procedure of allocating channel groups for all the cellular base stations within the system is called the frequency reuse or frequency planning. So this is one of the important work while designing any cellular system, that is your frequency planning. So in our industry, our radio frequency planning engineers will basically go into this particular work only. Obviously, this particular task is quite complex. That is, those engineers will going to analyze or study the traffic analysis, geographical conditions, user demands, etc. So they have to incorporate lots of parameters into account, and by a certain simulation analysis or some physical signal testing analysis, they will going to perform this frequency planning. So now let us understand with this particular example of our state UP, that is how we will going to perform this frequency planning, whatever we have studied in our previous slides. So suppose that this is the geographical area UP where we have to deploy a new cellular communication system. So for this particular region, how we will going to perform this cellular planning? So suppose initially we will be having a particular cell, which is nothing but the coverage of your base station, and we have assigned certain frequency ranges to this particular cell. Then all the neighboring cells will be showing here in this different color, which are basically imparting this sort of information that all these neighboring cell sites will not going to have same frequency band. They are basically possessing different frequency band for their signal transmission as well as reception. All the group of those cells which are basically having different frequency ranges for their signal transmission, they would have been considered as your cluster or called as your cluster. So when we have maintained this particular cluster, what we will going to do is we will going to replicate this particular cluster throughout the geographical area so that we can cover up the entire geographical region, so that we have got the coverage throughout the state. So this is what we have to do for deploying a cellular system. So this is particularly showing the base stations, or you could say your antennas, and this hexagonal structure are basically showing the coverage of these base stations. So this is how we will going to perform the frequency planning. So hopefully you guys have got the idea about the frequency planning and the basic concepts of your cellular system. In case of any doubt, you can ask me in the comment section. I'll try to solve them out as soon as possible. So these are the references that we have used while preparing for these slides. Thank you very much for your patient hearing.